Guys, this is Mr. Y, and today I will be absent. So I want you to please carefully listen to the instructions I have for you here. Today you will be completing classwork lesson 1.5, which is the bike race. And we will try our best to also complete the homework associated with the lesson. Remember, if you ever forget what the classwork is for a day or what the homework is for that specific day, for that night, that evening, then you also have the calendar on your packet, and that helps you identify what the classwork and the homework are. So please make sure you complete your work, stay on task, be respectful to the sub, and make sure you are engaged on task. The sub will report to me. They will let me know if people were not doing their work. They will let me know who was not doing their work. And I hope that I will have a list of nobody who will not be doing their work. So please make sure you are on task and listen carefully to instructions and the instructions in this video so that you learn how to complete and understand well how to complete this lesson. So starting with the bike race, we have a task and it says Antonio and Juan are in a 4-mile bike race. The graph below shows the distance of each racer in miles as a function of time in minutes. So notice we have, just like we normally do, two axes, the x-axis or the t-axis in minutes, the y-axis, or in this case, the distance axis in miles. And be careful because it looks like the x-axis is in 1 unit, which is very common. Whereas while the y-axis is jumping in halves, right? So this is 1/2, then 1, then 1.5, then 2.5, and so on. So I would like to mark them just to get that out of the way. You don't need to, but it's kind of nice to have them. Okay? And so on. So the first question is, who won the race, or who wins the race, and how do you know? Now, to understand or to know when someone wins the race, when does a person win the race, right? The person wins the race when he or she finishes the race in the shortest amount of time or shorter amount of time in comparison to the other people, the other individuals. So in this case, we are looking for the same distance, but one that is completed earlier than the other. So if you notice, if we look at the end of these lines or these graphs, you will see that Juan ends up here. This is Juan's graph, and that's on the 4-mile mark in terms of the y value, right? And similarly, Antonio ends at the same y value, at the same height, which is also the 4-mile mark. So both of these individuals finished the race, finished the 4-mile race. The difference between them is that Antonio finished it for an x value or a t value of 15. So for instance here, Antonio has an ordered pair here at this point, right? This point here, Antonio, is 15, 4. Whereas, while Juan finished here, and the x value for that, or the time for that, is 13. So Juan, just at that point, has, I'm talking about this endpoint. So if I were to call this J, and I'll call the other one A, then at this point, Juan has an ordered pair of 13, 4. Notice both of them have the same y. One has a shorter time, a lesser time by 2 minutes, which means that Juan completed the race faster. So to put this in words, we can say Juan won the race, to answer the first part of the question. And then how do we know Juan finished, or he finished the race, the 4-mile race to be exact, in 13 minutes, while Antonio finished or completed the race, the same 4-mile race, in 15 minutes. Okay, you can say, don't add too much information. You can say, Juan was 2 minutes faster, but you don't need to do that. Okay, so this is clear and good enough information to justify, to provide a response or an answer, which is who won the race, and then to also say why they won or he won the race. So this is the first part. Part number two, create a table for each of the functions described in the race. So when you get a question like this, what I want you to think of is always have a plan, always look ahead. So what I would do is when I'm asked to create a table and I automatically see a table, I try to assess what the table is about. And here I can see that I have 1, 2, 3, 4, 5, 6 spots, 6 columns. So in my mind, I'm creating, remember, these are input output. So this is an X value and this is a Y value. Or in this case, it's a time and distance. So in my mind, I'm thinking of 6 ordered pairs. 6 ordered pairs for Juan and then 6 ordered pairs for Antonio. So where do these ordered pairs come from? They will happen to come from the graph. I will have to find them in the graph. Having found this point here, this one endpoint, that is the last point on the graph. So I still need 5 more. So I can actually place this point for Juan. I can put it here as 13 for X and 4 for Y. And I also know for Juan, this is the graph for Juan. Okay, this is the graph for Juan. Just be careful. So also I know for both of them, actually, the starting point is 0, 0, because it looks like both these graphs start at the origin. So I also know that for Juan, he started at 0 time for 0 miles and vice versa. Now I have 4 more points. So how do I find these points? Traditionally, what we did is we looked for corner points. So for example, I would not find a point randomly here, right? And try to find its X and Y values. Instead, I will probably go with, and let's kind of spread them out, maybe 3,1 right here, or 3,5, just be careful. I was almost tricked by the 1 value. So 3,1/2, that's a point. Another point is, we need 3 more. So I'm going to choose maybe 1 here. I'm trying to see if this is exactly through the point. Okay, that's fine. I think it is. So 6,1.5. This point is a good point because it's a point of intersection. Okay, so that's 7,2. And maybe 1 point on this other end. And we can pick maybe this point. This is a good point here. And if you forget, just map it because it's easier this way. So it's going to be 11,3.5. Okay, so this is the set of points for Juan's curve. Now, similarly for Antonio, I'll use the orange color. We also said this endpoint here is 15,4, right? So this goes here, 15,4. And also Antonio starts at the origin. So that's 0, 0 for Antonio. Now, Antonio, we need some points. This is a point. We need 4 more points, right? This is a good point. The point of intersection is another point. And let's try maybe this point here. So that's already 1, 2, 3, 4, 5, 6. Yep, those are good. So 3,1, this point right here, 3 to the right and 1 up. And this point here is 5,2. 5 to the right, 2 up. This point here, 7 to the right and also 2 up, 7,2. And notice they have the same 7,2, right? Because it's a point of intersection on both graphs, or for both graphs. And then the last point here, which is 11,2.5. Now, it's kind of nice to have, notice it's kind of nice to have similar X values, right? And see how the Y values were different. These are not all of them are the same. These are similar X values. And notice here, Juan at 3 minutes was at 0.5, while Antonio was a little bit ahead. But at 7-minute mark, they both had the same, basically Juan caught up. That's what the story is telling us. And then at 11, Juan is at 3.5, whereas Antonio is at 2.5, so that means that Juan surpassed him. Okay, or passed him. And, and this is evident on the graph because the graph of Juan is now above the graph of Antonio. And that's how we know that one is, past the other. So these are good ways to interpret the graph. Let's move on. Let me see if I can make this a little bit. I don't want to make it too small. Let's see if I go. Okay, it doesn't have enough. Yeah, it says describe. So let me see if I can. Describe the race during the first 7 minutes. So let's keep it 4 in this on this screen because I don't want to mess with the numbers. So it says describe the race for the first 7 minutes. So how do we do that? How do we describe the race for the first 7 minutes? What do we do here? This first 7 minutes is up to here, right? And now I'm going to erase technically this part. What's happening in this window, right? What's happening in this window? And let's kind of tab it up. And this is 4.3. During the first 7 minutes, which graph is higher? Which one is above the other? The lighter graph is above. So that's basically, just to clarify here, so you're not lost on this. You can erase all these, right? You have them, you can pause and go back. So what really happened here? This is the 7-minute mark. The first 7 minutes, this graph here, the darker graph, is under this graph here, the lighter graph. So the graph that is darker is Juan's graph. So during the first 7 minutes, what's going on? How do we describe this? We say during the first 7 minutes, basically whoever is above is what? Is it faster? Is it slower? Think about it for a moment. Notice first also the first 5 minutes, the graph of Antonio is going higher. Right? So in 5 minutes, he had gone to 2 miles, whereas in 5 minutes, Juan was still below. So during the first 5 minutes, Antonio was ahead of Juan. They both, to be specific, they both started at the origin, start line. You can call it start line. And what happened at the 7-minute mark. And you can say Antonio stayed ahead until the 7-minute mark. This is when Juan caught up to him. So basically, this is what happens. Now, this answers the question, describe the race during the first 7 minutes. What is happening during the time from the start of the race until the 7th? So I described that and then explain how you can tell. We can tell this by looking at both graphs and seeing that Antonio's graph for the first 7 minutes is above Juan's. Okay, this is more than enough explanation. So this basically concludes this part of the of this page or this topic. Okay, so make sure you understand it, you know it well, and you can replicate it, or you can do this on a quiz or on a test. Now let's move on to the second page. This is on and questions. Yep. The second page it says, imagine you were watching the race and had to announce it over the radio. Write a story. So I gave you some information. What I'd like you to do is to write a story about it. I'm going to let you write your own story and be the announcer. Okay. So number 4 is for you to complete on your own now that you have the information that you have. Take a couple minutes and do that. Number 5, does Juan's graph represent a function? Why or why not? So if you look at the graph, go back here, difficult to be in 2 pages at once. So this is too small. So excuse me. So does Juan's graph represent a function? Now remember, when we talked about functions, we dealt with the vertical line test. And here, no matter where we draw a vertical line, if we're dealing with Antonio's graph or Juan's graph, think about them, they're separated, right? Each of them. So this is a graph by itself and the other one, right? And the other one is a graph by itself. And something like this. So each one of them is a separate graph. But if you draw a vertical line through either one of them, it doesn't cut at more than 2 points. So when they ask us for these functions, unless you see a vertical line here, which we don't. So yes, they're both functions. So let's go back to the question. And the question was, does one graph represent a function? We can say yes, it does. It passes the vertical line test, or you can also say for each input, which is time, on Juan's graph, there is at most or a unique output. And the reason is going to be the same for Antonio. Okay, same idea. Yes, it does, or it is a function, because they said, does it represent, right? So yes, it does represent. Yes, it does, same thing. It passes, or the graph passes the vertical line test. Come on, the vertical line test, and then you can say the same thing for each input. And most one up. Okay, so this is pretty much it. And then let's move on to the next part. Number 7. Again, you can feel free to pause, right? Number 7 says, let's call the function representing Juan's race J of t, J for Juan, and the function representing Antonio's race A of t for Antonio. What does J of t equal? So remember, J of t, A of t, all these f of x, right? All these are y equals. These are y values. So then the question says, what does J of t equal to A of t? This is like saying, when is the y value for Juan equal to the y value for Antonio? So this is like saying, when are their heights? Remember, y is the height. We're saying, when are their heights equal? What does it mean? It means their heights are equal. So it says, the question says, when does? That means for which x values? Remember, if we're comparing y values, that means we're asking for the x values. When we talked about this earlier or before. So when are they equal? If we go back, and then what does it mean in the context, right? So if we go back to the previous page, when do the functions, or where the functions equal to each other? That means, where do the graphs intersect? That's what that means, where the y values are equal. This is where the y value is equal. So this is 2 for y value for Juan, and it's also 2 for Antonio. When are they equal? And that was also in the table. That was at the value 7, right, for x equals. So basically, we're saying at 7 minutes, they are at the same mark, which is the 2-mile mark. Okay, that's what we're saying. So that's how you answer that. And you can, to be specific here, you can go back and say, it says, when do f of t? So for which, not x value, but here we're using t. You can say g of t is equal to A of t when t equals what? When t, which is the independent variable, equals what? 7 minutes. Right? And then it says, what does this mean in the context of the race? Right? What does it mean? We just said that. At t equals 7 minutes, Juan caught up to Antonio. Remember, Antonio was ahead, Juan caught up to him. And then, so this is the context of the question, right? The context of what J of t and A of t mean. For number 8, it says, for what intervals is J of t greater than A of t? So when is J of t greater than A of t? J of t is greater, that means the y value is above. So remember, let's go back here to the previous page. When is J of t greater? J of t, Juan's graph. When is, remember, Juan's graph is, again, this is like, you may mistake which graph is which, but Antonio is this one, okay? And J or Juan is this one. So when is J of t? This is J of t. And this is A of t. They're saying, when is J of t greater than A of t? That means when is this y value above? The greater means above. Because that's how the y values are greater, they go above. So when is the graph of Juan's graph above? All this time, if you go all this time here, it's below. It's below until this point. Here is where they meet. And I'm gonna put this in a different color in pink. After this point, J of t is above. So if you're saying from this point and on, or after this point. So when is J of t above? You would say J of t is above A of t for t. When is it? After this point. And what's this point? This is 7. For t greater than 7. So when t is greater than 7, when t is after 7, the graph of J of Juan is above the graph of A, Antonio. And what does this mean in context? In the context of this question, to answer the other part, in the context of this question, this means that Juan advanced on or over Antonio, or surpassed, right, or passed him. He just basically took the lead. And that's pretty much it. That's the context, because the graph is above, that means he's going basically, not only they were at the same point at 7,2, they were at 7 minutes at 2 miles, but then Juan took over. Okay, so this is pretty much this part, and that was question number 7, 8, I believe. Now number 9, what does the interval, same thing, for what intervals are J, okay, we didn't talk about interval. When is J of t? We said when, we said after 7, right? So it's better to do it in intervals for number 8. At what interval, this is J. When is J of t greater than A of t, right? At one interval. It's greater, that means from here, we said from here and on, from 7 and on. So which interval? J of t, you're gonna say J of t, that was for 8. J of t, because they asked for an interval, is greater than A of t. Originally, I said for t greater than 7, right? But we don't like this notation. Instead, when you need to write, you can say on, let's do it here, on what? Open circle 7, comma what? Comma the end. Where's the end? How far the end is, right? So from 7 all the way to what? I mean, here you have to be careful because you can say the end is what? You can say the end for J is 13 minutes. At 13 minutes, that's it. Juan reached his goal, he reached his finish line, And that's it. He probably waited there for Antonio to catch up and get there at the 15th minute mark. So you can say on 7, 13, because that's 4, or 15 if we're talking about the whole race took 15 minutes if he waited, right? So you can do it this way. This is what a better interpretation is, or a better interval notation is. For when they asked for the following question, they said, when is A of t greater than J of t? On which interval? And what's the context? And this happens actually here. This is Juan. This is Antonio. Antonio here is above. So Antonio is all the way above to here. So technically, between you're saying between this point from the beginning, well, not exactly at the beginning, because at the beginning they're exactly the same, up to this point. And you don't want to include them. So you're going to say A of t is larger, is higher than J of t, right? For which, on 0 open and up to 7. So between 0 and 7, A is above, okay? Greater means above. And in this context, what do we mean? We mean that in the context of this question, this means that Antonio is ahead of 1. Again, that was for number 9, okay? This was for number 9, this part. This was previously for number 8. So this is pretty much the interpretation for these questions. Make sure you understand them, you write them down, and this is it. Task number 2 real quick. It says, check the graph f of x and then answer the questions 1 through 7. Unless otherwise specified, restrict the domain of the function to what you see in the graph below. Approximate answers are acceptable. Okay, that's fine. What is f of 4? This is really spiral review. This is review. What is f of 4? Now, for those of you who are struggling with this, or have struggled with this, notice, always ask yourself, what are they giving me? Are they giving me x and I'm finding y? Or are they giving me y and I'm finding x, right? So in this case, remember this is f of x. So they're telling me x is 4. So if they're telling me that x is 4, they're probably asking me what is y. Okay, and the way this works is if x is 4, this is x is 4. What is the y value for x is 4? If x is 4, what we do at the x value 4, we map onto the graph and it lands here. So the corresponding y value for that is 1. So what is f of 4? F of 4 is 1. That means what is the y value at x equal to 4? You would say f of 4 is 1. And this is kind of like saying 4, 1, the ordered pair. That's what it's saying. What is f of 6? Same thing. You go on to, by the way, just be careful here. We're going to get to that in a moment. So f of 6, this is f of 6. It lands here. What is the y value for this point? We go backward here. It's 2. F of 6 is 2. And so on. What is f of 2? F of 2 maps here, lands here. This is f of 2. It's 4. F of 0 at 0 at the origin. Again, I'm going up because my graph is up. If I had a graph down there, I would go map down. So f of 0, how far up? At 0, you go up 7. F of 0 is 7. And so on. Now, the next part is things are reversed. They're saying for which values is f of x 3. Remember, f of x is the same as y. They're telling us the y value is 3. And they're saying for which values, that means find x. So remember, either given x, find y, given y, find x. Here we're given what? We're given the y, the f of x. So we're finding the x value. So we're saying, or they're telling us, and let me clear this up here. They're telling us the y value is 3. So how do you do that? This is how you do this. The y value is 3 here. This is the y value. Map it onto the graph. And it lands about right here. Right? Now, also, if you think about it, you can continue mapping it. And there's another value, the x. So here I'm going to say, it's not 2.5 exactly. I would say 2.6. So let's, or 2.7, right? Yeah, something like that. 2 point, yeah. So we're saying this value here is 2.6. It has a y value of 3. And this value here, 8, has a y value of 3. So for which values, you can say x equals 2.6, and what else? You can put comma 8, or you can say also x equals 8, either way. Now, number 6, it says for which value, same thing, is f of x equal to 0, the y value. This is the y value 0. Which x value, right? Which x value? If you want to find the x value, you want to go and map on this. And go like this. So it lands here. You're saying technically this point, you're saying calling it 10, comma 0. So if they ask you, when is y equal to 0? When x is 10. So for x equals 10. All right. So just be careful with these things. They may be tricky. They may be a little bit kind of tedious, but just practice them a couple of times. Now, what is the domain? Domain is the x values. So domain is wherever the graph starts on the x-axis. So you're going to map like you're mapping, you're holding the graph between two vertical lines. So the graph starts here, and this maps down to 0. It is included because this point here is included, and it goes all the way to the right to 10. So your graph is between 0 and 10 included. How do you say that? You would say the domain, because both of them are included, you put bracket 0, 10 bracket. Interval of increase, that's a different question. So interval of increase, that means tell me where the graph is going up. Where is this graph going upward? This is increase right here. And that's the only place where the graph is going up. So how do I put that interval? I would say from 4 to 8. You're saying from 4, between 4 and 8. And they say interval, that's like x interval, okay? That's what they mean, x interval. From 4 to 8, the graph is going upward. So you can say what? 4, comma 8. Now, can you say put brackets? Sure. But normally to say increase, we put them in parentheses. Okay, it's a common notation thing for intervals. Interval of increase and decrease, normally you put them in parentheses. Now, it says the function d of t represents, so we have a new question now. If you have questions on this, please write them down right on the side, and next time I'm in class, I'll help you with it. But for now, hopefully you're taking notes, you're completing the work. And for number 11, 12, and 13, the question says for 11, it says the function d of t represents Gulliver's distance from home after t hours. Number 11, what is d of 2? So again, they're giving you the x value 2. This is the x value 2. Don't go here on the y-axis. It's not the y, it's d of x. And now it's d of 2. That means x is 2. So how do I find, if I'm given x is 2, I need the y value. Okay, to get the y value, I map onto the graph. It lands here, if I go to the right. So technically, you're saying 2, comma 4. So here, when they say, what is d of 2, and what does it represent in the context? So you can say, let's type it up. D of 2 equals 4. This means that what? There's time of 2 hours, and the distance is 4, right? This means that Gulliver had traveled what? He traveled 4 miles in 2 hours, right? Or he's, is it distance from home? If it's distance from home, that means in 2 hours he's travels 4 miles, maybe away from home, right? In 2 hours. just to be a little bit more, because he's going away from home. Now number 12, what does d of 5, what is d of 5 on what it means? So again, d of 5, to go to 5, you go to 5 here. And then that's basically 11. So let's say d of 5, d of 5 is 11. And then what does this represent? By the 5th hour, he's 11 miles away from home, because it says distance from home. So we can say at the 11-hour mark, Gulliver is 11 miles away from home. Okay. So this could be context. I don't think they want more detailed context than this. And then for which value is DFT5? Now this is also reverse engineering. When they say DFT, that's Y, right? They're saying the Y value is 5. So on the Y axis, you go to 1, 2, 3, 4, 5 right here. This 5. This DFT is 5. And then you map onto the X axis. So it maps here once, just to be clear here, right? It maps here once. And it also maps, if you continue, it hits the graph here as well. So there are two values of X that give me the value of 5 for Y. And they are these points. So what are the values? One of them is, so this is technically 4, 5, and the other is 8.5, 5. So what are the values? For which, that's why they said for which values. What are the values? Values t equals, remember t is the X value, or t is, we said 4 minutes. Let's call them 4 for now, 4, and t equals 8.5. What does this mean in the context? So let's put some context to that. Gulliver would have traveled 5 miles. Oh, would be, I shouldn't say traveled, would be 5 miles away from home at the 4-hour mark. And then the 8.5-hour mark, or in 8.5 hours. If you don't want to use the word mark, you want to say in hours. That's also accepted. So hopefully this is helpful. And let's see, maybe we can get started on homework. Make sure you take notes. For homework, let's start with 151. F of x is 2x minus 3. Find the following. So this is also something some of you are struggling with, even though it's pretty straightforward. It's asking you to plug in -2 into x. So f of -2 is 2 multiplied, this is spiral review, 2 times -2, and then minus 3. And that gives you -4 minus 3, which is -7. F of 7 is 2 multiplied by 7 minus 3, which is 14 minus 3, which is 11. F of -4 equals 2 multiplied by -4 minus 3, which is -8 minus 3, which is -11. Just be careful you remember how to add negatives correctly. Second part, number 2, they're giving you k of x and they're saying find k of 0. Okay, k of 0 equals plug in 0 for x. That's what it is. -7 times 0 is 1. -7 times 0 is 0. Plus 1 is 1. Now, same thing, -7 times -1, plug in -1 for x, plus 1 Negative times a negative is positive, and then 7 plus 1 is 8. Okay, f5, negative 7 times 5 plus 1. Negative 7 times 5 is negative 35, plus 1 is negative 34. Okay, this should be straightforward. Number 3, let's move up here. Okay, so number 3 says a souvenir soda cup at a theme park costs $10 to purchase, but then each refill is only 50 cents. So we're paying 50 cents per refill. That's automatically to tell us that this is the rate of change, aka the slope. So you have to pay an initial fee of $10 regardless, right? So let's write this is basically your B, this is your M. So how do you write a function rule? Careful, when they say function rule, they're expecting you to write what? F of x. This becomes f of x equals to 0.50x, and then what? Plus 10. And then part B, find f of 4. All you have to do is just plug in 4. So you do 0.50 times 4 is 10. And this is 2 times 2, basically 0.50 times 4 is 2, plus 10 is 12. Okay, I hope this is helpful. Maybe I'll do one part and then I'll let you try for on your own for homework, okay? So you're gonna get some practice in. Numbers, part C, interpret your solution for part B. What does it represent in the context of the situation? So let's go back and read what the question said. The question had said a souvenir soda cup at a theme park costs $10 to purchase. And then what? Then each refill is 50 cents. So what does part B mean? F of 4. F of 4 means you are getting 4 refills because the refill is basically the x value. And each refill is costing you 50 cents. So here, let's interpret this. So for part B, you're saying it costs $12 to get 4 cups of soda at this theme park. 4 in total. It could be the original plus 3 refills, but 4 in total, right? That's pretty much it. Double check, make sure everything is fine. 50 plus 10, yep, everything looks good. So it costs $12 to get 4 cups, exactly. If you have any questions, please save them. You can ask them while the sub is there, or you can save them to me when I'm back. But I feel this is helpful and this is easy. It's not that difficult. It's just work. Sometimes it's busy work, but it's not super difficult. So again, feel free to pause the video, go back, watch at your pace, and then hopefully this will help you finish. You only have really number 4 to do on your own for your homework for tonight. And hopefully I will see you on Friday. You guys have a good day, and I'll see you soon.